Okay, so we're going to try to derive the logistic population growth model next. Starting with this, we're going to plug these factors for B prime and D prime in to this model. And so we get dn dt equals, in place of B prime, we're going to put B minus A times N, minus, in place of D prime, we're going to put D plus C times N, and then this whole thing times N. All right, then we can rearrange the terms, and we can pull the N out from the inside here. And so we're going to get B minus D minus A plus C times N times N. Okay, so we basically took the AN and the CN and put them together, and pulled the N outside, and took the B and the D and put them together. All right, so we just rearranged the terms using algebra on the inside. Okay. Then we can multiply this whole thing by anything that's equal to 1, right? And so if we use this term, B minus D over B minus D, that seems kind of ugly, right? But if this is equal to 1, if we multiply that by this whole thing here, B minus D minus A plus C times N times N. If we multiply this all through, it allows us to simplify this equation further, although it doesn't seem like it, right? So then we're basically dividing by B over D, and so that goes away. And we can get this one divided by B over D. We still have this on the top, and we end up with N on the outside, so we end up with something like this. We still have a B minus D out here. And then on the inside, we get B minus D divided by B minus D, right? And those are gonna disappear. Minus, we get A plus C over B minus D. And there's an N there still, and there's an N there still. And so this is going to go to 1, right? So, well, if we remember, B minus D is also equal to R. So R is equal to birth minus death rate. So we get R on the outside. And if we pull this N over here, we get it there. And then this is going to go to 1. 1 minus A plus C over B minus D times N on the inside. All right, so let's hold on to that for a second. And if we look at this term here, because these are all constants, A's and C's and B's and D's, we can define a new constant, K. And if K is equal to the birth rate minus the death rate divided by the constants A plus C, then we can see how that would go in here, but upside down, right? And so this whole thing then turns into R times N, 1 minus, and there's this N still, but the whole thing is divided by this new constant K. And that, my friends, is the logistic growth model. Okay, so you can see how we can get to this, starting out with this idea of density-dependent birth rates and death rates, which I think is pretty cool. All right, and so this whole thing then, just to keep in mind, the first part of it, right? We don't want to lose sight of that, is dn over dt. And yep, I didn't make any mistakes that time. All right, thanks.